Welcome to The Explainer. Today, we are tackling one of the absolute cornerstones of data science and analytics, linear regression. It really is the powerhouse behind so many predictions, from stock prices to, well, sales, which is what we're talking about today. So let's put you in a hot seat for a second. Imagine you're a marketing director. You just spent a cool $1 million on a big new TV ad campaign. Your boss walks in and asks that one simple question. So, was it worth it? How do you even begin to answer that with any real confidence? Well, this is exactly the kind of problem that linear regression is designed to solve.
All right, let's get into it. To give that marketing director a real answer, we first have to wrap our heads around the core of the prediction problem itself. We've got to find a way to mathematically define the relationship between our ad budget and our sales numbers. And really, at its very heart, that's all this is. It's about drawing a clear line, a connection, between two things. We've got something we can control, right? Like our advertising budget. We're going to call that the predictor. And then we have the outcome we really care about, like sales, and that's our response. Linear regression is the tool that helps us find the actual mathematical link between them.
And here's the official name for what we're doing: simple linear regression. Now, the key word here is simple, and that's because we're starting out with just one predictor, our TV ad spending, to try and predict one response, which is sales. The whole goal is to draw a single straight line through all our data that best shows that relationship. So that leads us to the first really big question. If you've just got a chart with a bunch of data points scattered all over it, how in the world do you find that single perfect line? Our mission, should we choose to accept it, is to find the one straight line that best slices through all our data points. This line is going to become our prediction machine. But just look at all those points. I mean, you could draw a nearly infinite number of lines through them, right? A super steep one, a really flat one that's just kind of tilted. Which one is actually the best one? We can't just guess. We need a consistent, mathematical way to figure it out. And this brings us to this brilliant solution called the least squares method. Here's how it works, and it's actually pretty intuitive. For any line we decide to draw, we can measure the vertical distance, that's the error, from each and every data point down to our line. Then we square all of those little errors and we add them all up. The best line, it's simply the one line that makes that grand total of errors as small as it can possibly be. Okay, great. So we have our best line, we use the least squares method, we found it. But now for the really important part. Can we even trust this thing? Is our model actually any good at predicting stuff? We can't just squint at it and go, yeah, looks pretty good to me. We need a score, a grade on a report card, a number that tells us objectively how well our line actually fits the data we have. And for our model, the one that's predicting sales based only on the TV ad budget, that grade is 61.2%. So, what on earth does that number actually mean? This number is called the R-squared value. And honestly, the best way to think about it is like this. Imagine all the reasons your sales go up and down is one big mystery story. R-squared tells you what percentage of that story your model actually explains. So an R-squared of 61.2% means that our TV ad budget all by itself explains over 60% of why our sales fluctuate. That is a huge piece of the puzzle. And the software we use to run this gives us even more detail. Now, don't get too hung up on all these numbers, but look at the p-value for TV. It's crazy small, right? That just confirms that this relationship is real, it's not some random fluke. But the really juicy part is the coefficient, 0.0475. That number is the slope of our line. And it means for every extra $1,000 we spend on TV ads, we can expect sales to go up by about 47.5 units. Now that is a number you can take back to your boss. So we've pretty much confirmed that TV ads have a real, measurable impact on sales. But is that the whole story? Of course not. The real world is way more complex than just one straight line, which brings us to our next big idea. Okay, so up until now, we've been using simple regression. Think of it like a recipe with just one ingredient. But what if we want to make a more interesting, more complex dish? Well, that's where multiple regression comes in. It lets us add more ingredients, more predictors, to see how they all work together to create the final outcome. And this is absolutely crucial because, let's be real, sales aren't just driven by TV ads. They're also influenced by what you spend on radio, on newspaper ads, on special promotions, you name it. To build a model that's actually useful, we have to account for all this complexity. So let's see what happens when we throw our radio and newspaper ad budgets into the model too. Check this out.
Our R-squared, our model's grade, shoots up from 61% all the way to 89.7%. That's a huge leap. Just by adding in more of the real-world factors, we get a much more honest picture of what's going on. Our model just got a massive upgrade.
But wait, there's an even cooler, more powerful idea we can explore. What if the different types of advertising don't just add up? What if they actually multiply each other's effects? What if running radio ads actually makes your TV ads even more powerful? In the world of statistics, this is called an interaction effect, but you probably know it by its business school name, synergy. It's that classic idea that 1 + 1 doesn't equal 2. Maybe it equals 3, or even 4. The whole is way greater than the sum of its parts. And this right here shows you just how powerful that idea is. When we build a new model that specifically includes a term for the interaction between TV and radio, basically a term that represents their synergy, our R-squared jumps again, this time to an incredible 96.8%. Think about what that means. After our last model, there was still about 10% of the sales story that was a total mystery. By adding just one little term for synergy, we just explained nearly 70% of that remaining mystery. The real magic wasn't just in TV or radio by themselves, but in how they worked together. Okay, let's bring this all home. Why does understanding a concept like linear regression really matter? Whether you're in marketing or finance, or frankly any field that has to deal with data. So let's do a quick recap. We've seen that regression isn't just about drawing lines, it's about finding real patterns. We learned how R-squared acts like a report card for a model's storytelling ability. We moved from a simple one-ingredient model to a more complex one that mirrors the real world. And maybe the coolest part? We found out that the real magic can happen in the interaction between things, those hidden synergies that are what truly drive results. You see, this isn't just some dry statistical technique. It's a whole new way of asking questions. It gives you the power to go beyond gut feelings and find the actual drivers of success that are probably hiding in plain sight. So the final question is really for you. What relationships, what synergies, what hidden patterns are just waiting to be discovered in your data?